In this lesson, we're going to be talking about types of attacks. One type of attack that you'll find common, particularly in cases of hacktivism, for example, or cases where people are trying to make a particular point or just be a general pain, is this idea of defacing. Defacing goes back for quite a while. It's the idea of sort of digital graffiti where you've left your mark or your imprint behind so that everybody knows you were there. Primarily a website thing, and it's really just making alterations to something. It used to be pretty common a long time ago to have particular businesses or people or just organizations in general to have their home pages be replaced by this other thing that was along the lines of, hey, I was here and I took over your page. We also have a pretty common one, or certainly has been common over the years, and it's a pretty good path towards quality exploits and high-profile vulnerabilities, and that's buffer overflows. A buffer overflow is a result of the way programs are stored in memory. When programs are running, they make use of a chunk of memory called a stack, and it's just like a stack of plates. When you put a bunch of plates down, when you pull a plate off, you're going to pull the top plate. You're not going to pull the oldest plate. You're going to pull the one that was on top. So the same thing with a stack here when we're accessing memory, and this has to do with the way functions are called in memory. When you call a function, a chunk of memory gets thrown on the top of the stack. That's the chunk of memory that gets accessed. And you've got a piece of data in memory within that stack, and that's called a buffer. And when too much data is sent and tried to put into that buffer, it can overflow the bounds of the configured area for that particular buffer. Now, the way stacks are put together, we end up with a part of the stack where the return address from the function is stored. So when you overflow the buffer, you have the ability to potentially overwrite that return address, at which point you can control the flow of execution of the program. And if you can control the flow of execution of the program, you can insert code into memory that could be executed. And that's where we get buffer overflows that turn into exploits that create the ability to get like a command shell or some other useful thing from the system where the buffer overflow is running. So that's a buffer overflow in short. We also have format string attacks. And sometimes these can be precursors to buffer overflows. Format strings come about because the C programming languages makes use of these format strings that determine how data is going to be input or output. So you have a string of characters that define whether the subsequent input or output is going to be an integer or whether it's going to be a character or whether it's going to be a string or a floating point, that sort of thing. So you have a format string that defines the input or the output. If a programmer leaves off the format string and just gets lazy and provides only the variable that's going to be output, for example, you have the ability to provide that format string. If you provide the format string, what then happens is the program starts picking the next pieces of data off the stack and displaying them. Because of that, we can start looking at data that's on the stack of the running program just by providing a format string. And if I can look at the data, I may be able to find information like a return address or some other useful piece of information. There's also a possibility of being able to inject data into the stack using this particular type of attack. Denial of service, this is a pretty common one. You'll hear about this a lot. This is not to be confused, though, with the one that I'll be talking about after this. A denial of service is any attack or action that prevents a service from being available to its legitimate or authorized users. So you'll hear about a ping flood, a SYN flood, a Smurf attack, and a Smurf attack has to do with ICMP echo requests and responses using broadcast addresses. That one's been pretty well shut down over the last several years. You can also get a denial of service simply from a malformed packet or piece of data, where a piece of data is malformed and sent into a program. If the program doesn't handle it correctly, it could crash. If it crashes, suddenly you're not able to use that program anymore. Therefore, you are denied the service of the program, thus a denial of service. As I said, a denial of service is not to be confused with a distributed denial of service, and I know it's pretty trendy, particularly in the media, to call any denial of service a DDoS. Any denial of service is not a DDoS. A DDoS, or distributed denial of service, is a very specific thing. A distributed denial of service is a coordinated denial of service making use of several hosts in several locations. So if you think about a botnet as an example, a botnet could be used to trigger a distributed denial of service, where I've got a lot of bots that I am controlling from a remote location, and I'm using all of those bots to do something like sending a lot of data to a particular server. When I've got a lot of systems sending even small amounts of data, all of that data can overwhelm the server that I'm sending it to. So the idea behind a distributed denial of service attack is to overwhelm resources on a particular server in order to cause that server not to be able to respond in a normal way. The first known DDoS attack used a tool called Stacheldraht, which is German for barbed wire. Stacheldraht came out of some work that a guy by the name of Mixter was doing in 1999. He wrote a proof of concept piece of code called TFN, which was the Tribe Flood Network. The Tribe Flood Network was then turned into something called Trinu, and Trinu was used as more or less the basis for this program called Stacheldraht, which was then used to attack servers like eBay and Yahoo back in February of 2000. So that attack in February of 2000 was really the first known distributed denial of service attack, which is not to say that there weren't denial of service attacks previous to that. There certainly were plenty of them, but they were not distributed in nature, meaning there weren't a lot of systems used to coordinate and create a denial of service condition, and therefore we get the distributed denial of service attack. So that's a handful of types of attacks and some pretty common attacks that you're going to see.